My name is Freddy Christensen. I'm a program management architect based in Vedbæk, Copenhagen, so working with Thomas and Michael, who you probably saw a moment ago here on stage. I actually had to remove 2 slides from my presentation because Thomas showed them in his presentation, but I should be good now. So I'm here to talk about integration, and a lot of things have been demoed on integration earlier. I'm not going to show how integration is done from installing the CRM connector and setting up the CRM connector. If that's what you want to see, then you are in. I don't think there is a session for that actually. What I'm going to show on the CRM connector is more under the hood. What did we actually change in NAV to enable the CRM connector to go and do what it does? I'm going to show you how the CRM connector or how the adapter actually works. What is it doing in order to suck out data from NAV and send it on to CRM? So it's more like, how does it work underneath? I'm probably going to spend some time in PowerPoint, some time in the classic client, development environment, stuff like that, some time in our RTC, and some time in Visual Studio here. So it's a technical session, but then again, the title is TechDays, so you'd probably be disappointed if I was here to show how to install something using a setup program, stuff like that. After the CRM integration, I'm going to talk about cloud services, how to utilize some of the cloud services that are out there. When talking on the CRM integration, I'm going to touch upon web services because the entire integration between CRM and NAV in R2 is based on web services. So I'm going to show you some code on how to use web services from NAV. And then last but not least, I'm going to go through a end-to-end scenario on how to create a services order management system integrating with Windows Phone, the cloud, NAV, and stuff like that. So, let's get started. Oh, that's what I just said. So CRM integration was shipped in NAV 2009 R2, and in the beginning we thought that we had to modify like all tables to add some fields and all pages so that we could use web services and then get all of this data out in a special way. And during the end game of 2009 R2, we discovered a new mechanism to do these things, and we actually introduced a couple of platform features that would help us create this integration. So what we did in NAV was to add some to the platform, some triggers that would enable us to monitor what's happening. You all know that we have these on global triggers that is called whenever something is modified in any of the tables. In R2 we added some triggers that are called on even more on global, so they are actually always called. The original on global triggers were only called when you did something from the UI. I'm going to show how that works. When you want to enable the CRM integration in R2, you need to go to a page called Management Setup and click a checkbox. And let's just see that. So okay, I removed my okay. Anyway, you go to the Management Setup screen, and then you click this Enable Connector. When you do that, a number of things happens inside of NAV. The first thing is that a number of pages that we use for the web services communication is exposed as web services. We expose the integration service code unit as a web service so that we can actually interact with that one from our adapter as well. And then we run through all the tables that we want to integrate and update what we call integration record table. The integration record table is a new table added to NAV that contains a internal ID and an external ID for all the records that you want to integrate with a foreign system like CRM. The external ID is just the GUID, and the internal ID is our record ID. So of course, if you rename a record in NAV, you have to go into the integration table and rename that one. So that's the reason for not being able to give out the record ID, but I guess most of you already know all of these things. So let's have a look at what actually happens here in the integration record table. So table 5151, you have an integration ID, which is the GUID, and then the standard record ID, and a couple of fields on when this is modified and or when this is deleted. And all of these things are then kept in sync. Let's just open up that table in the classic client here. And have a look at that. 5151. And run. So as you can see here, we have like our integration ID, which is just some random GUID that has been created, and then the table from which, or to which this is linked, the page ID, which we would use this page in web services in order to get to that record, and then the record ID inside of NAV. The reason for not having a record ID is that if the record has been deleted, we clear out the record ID because we don't want to have something lying in here that this record ID was deleted at some point in time. If the user accidentally creates another record with the same record ID, which absolutely is possible, then that would be a problem. And we'll see modified on and deleted on, and these dates are actually the ones we use for integrating with the CRM connector. So having this table with everything in it, whenever you modify something, maintained, means that this is the table we can query from our external system in order to figure out what has been modified and what not inside of NAV. The database triggers in NAV, that's just, are always called. I think there's one exception to that, and that is when you rename something and then there is if you rename something and then that renames something else, then you in the rotator client actually will get an error if you try to do that, because that would mean that the on-database triggers would not be called, and that's going to be fixed in 7. The error actually mentions that if you want to do this, go to the classic client and do it, because then the triggers are actually called. That's a bad one. There's a code unit called 5150. That's where your enhancements go, or that's the one that actually keeps track of all these things. And let's have a look at that code unit, just quickly here. Design that one. So we have this is where we have the on-database triggers, which actually then maintains the integration record table. And the pattern here is very similar to what you've probably seen before, where you have the get database table trigger setup thing that is called whenever it wants to figure out whether these on-database triggers should be called. And if that table participates in the integration, then you want to have insert, modify, delete, and rename triggers called. And these functions then actually do the updated or insert and update integration record magic, you could say. So back to this one. The integration service, I mentioned earlier that one of the things that happens when you enable the connector is that the integration service is exposed as a web service. So we can actually, from the outside now, connect to that one and ask for what has changed in NAV since a given timestamp from a given page. That's what the connector does through the adapter. And I'm actually going to now create a small application in Visual Studio just to show how easy it is to actually track changes in the customer table in NAV. I could do it in NAV as well It's not quite as easy to do in NAV as it is to do in Visual Studio. So I'm going to use Visual Studio for that one. Of course, I could compile this as a DLL and then use that DLL in NAV if I wanted to do that. Let's just create a console application here. And this console application, we will start out by creating a reference to this integration service. So the integration service is the one that we monitor or ask for changes. I'll say add web reference, which is easier than adding a service reference. There's a lot of information on my blog on how to actually use web services in a simple way with service references and web references, all of these things. There'll be a link to my blog in the end of this presentation as well. So I'll say create an instance of the service, and that would be integration dot, and we want the integration service here. That of course needs to be a new one of these. Now what we want to do is we want to set the use default credentials, not user agent. Use default credentials. Having done this, I now have a proxy for my integration service on my NAV service tier, and I'm now able to communicate with that because I state that it should use the same credentials as my application is running as. So I want to create a next time equals dates time.now. The reason for this one, I'll come into that later, and do a loop while we don't press any keys. Then actually run around and monitor what's happening in NAV. So now we have the next time is kind of the time where we want to call NAV and ask, has anything happened since this time? And what we need to do is that every time we call, we mark the time of that call, and then that is the time when we call the next time. So the first thing I do here is this time equals date time.now, and then do the calling mechanism, and then after that say next time equals this time, and then let's have a small break so that we don't call a million times. So, and in between these lines, I now want to call the NAV web service and ask for what entities have been modified since the last time I called. So, the records I initialize here is what we call an XML port. So, the function that's called get modified records that we want to call has an XML port as a parameter, and we want to instantiate this one here. I'll show you the header of that in a second. Service.get modified integration items. That one takes an integration records XML port first, then a date time, a maximum number of records, and then a page ID to query from. So ref records, date time would be next time, max record I just want them all, and page ID 21. So this one will actually now return all customers that have been modified since now, which of course when I start this one is none. And I have to check whether the integration record is different from null, meaning that there are actually some, and now I can loop over them by saying this, and then based on that I can say console write line record dot, and then I can display the integration ID, but that would be a GUID. I can display the record ID, which would be a readable record ID, so you can see that actually it's working. So this is what it takes to monitor and track modifications happening in NAV. So you can see that this code actually is more or less, of course, a little more complicated than this, but this is the code that exists in the NAV adapter for the CRM connector. So if I run this guy, if I'm lucky, then it should work. I can start up NAV here, and go to my customers, and let's just open the Canon group and change the name like that. Okay. And within 5 seconds it should say customer 10,000 has been modified. And of course I can do the same again. And just to specify that, prove that it's not only customer 10,000 that works, I can modify another one and it tracks the same thing, customer 30,000. So this one is a very, very simple project, just displaying how to interact with the mechanisms of the CRM integration. I actually have a small application, a different application that I want to open that's called Monitor Changes, which does a little more than my application that I just typed in, but it's more or less the same, setting the same use default credentials, date, time, and it also checks for deleted records and modified records. And whenever there's a modified record in this sample, I go to the page that contains this record, namely in this case the customer card, and actually reads the record that was modified. And then I can here specify what modifications were actually done on that page. I cannot see on the entity which field were changed. I can just say that, oh, this field was changed, or this record was changed, and then I can replicate the data that I want to replicate from that one. So if I go to the Canon group now and change the name to the Canon group PLCX, this one is going to display to me the new name here, customer 10,000, my foreign GUID, and then the Canon group PCLCX. And if I change it back to PCL again here, it of course changes my data back. Yeah. So the various functions that are in the integration service that I used for this was get modified and get deleted integration items. There's also the get integration pages, which is called for getting what are all the data that are exposed as integration from the integration service. And all of these together are used from the CRM adapter to actually dynamically create the interface to NAV, meaning that whenever you want to expose new data for the CRM connector, you just go into the page and expose the data that you need to integrate to CRM and add that field there, and then you need to recreate the proxies from the CRM connector, and there's a good description of how to do that in the documentation of the CRM connector. So based on that, you'll actually be able to utilize the mechanisms put in place in these code units and these tables for integrating data from NAV to whatever you want to. So I thought I wanted to show that one. There's a number of special cases in NAV build-up. Child-parent relationships is one. If you in NAV just modify a child like a sales line or stuff like that, normally that doesn't update the header. So what we do is that in the integration management code unit, we actually find when we modify a sales line, we update the modified timestamp on the header of that one, so the CRM connector or whatever application you might have using that functionality will now get a message that this sales order has been changed, not only the sales line. There are some tables that are partially integrated, some contacts. We only integrate the persons to CRM. So if you wanted to actually have all contacts integrated to a different NAV system via this functionality, well, then you'd have to actually remove the line in integration management that only updates the integration record when the contact type is a person. You have different integrations for type tables like orders, invoices, and shipments, which are in the same table, but you actually want to handle them differently. And then we actually, for the sales order, if you delete a sales order, like when you post it in NAV, we actually do not delete it, because then the sales order would in CRM be marked as cancelled, and we thought salespersons would be frightened if their sales order suddenly was marked as cancelled because they were posted. And that might lead to people actually trying to type in the sales order once more. So, the demo I actually already did. And the code for the integration service, I selected to include all the code snippets in the presentation here because the presentation will be available, and actually you guys can then play around with this with Visual Studio and web services on NAV Microsoft. Okay, so much for the CRM integrator. Next up, utilizing cloud services, and after that, the Windows Phone end-to-end demo. I selected a couple of services in the cloud that I want to talk about. All of those have to do with Azure. Thomas talked about what Azure is in the keynote. We have these, he mentioned 7 data centers. We only have 6. 2 here in Europe, 2 in the US, 1 in Singapore, and 1 in Hong Kong. And he also showed you the image of the data center in Chicago, and if you calculate a little bit about on these 150 containers with each 2,000 servers, and each server is approximately 16 small instances, that actually adds up to 4.8 million server instances in Chicago running there. So the scalability of this is amazing. The 4 services I've selected to talk about here is the Azure Data Market, SQL Azure, Azure Storage, and the Service Bus. The Service Bus is particularly interesting whenever you have like on-prem NAV running that you want to integrate either to other on-prem NAV or services in the cloud, so you can actually communicate into an on-premise NAV using the Service Bus, but I'll show that in a second. The Data Market is not NAV. Data Market is Microsoft's attempt to standardize the way data is delivered. Everybody who has a set of data that they want to sell or they want to give away can do that through the Data Market. And the Data Market contains, I don't know how many feeds right now of data. And the idea here is that if you wanted to do these things like a couple of years ago, you would have to contact a vendor who you found out was selling some data. That could be geographical data, that could be sales tax information or whatever, VAT information, stuff like that. You should contact the vendor to actually get information about how can I buy this data from you and how do I integrate to that data. And a lot of cases you would get a COM object, and you would have a different calling mechanism to this COM object to get the data, and you'd have to work with that in different ways. On the Data Market, the idea here is that the technology is the same. We are using, as Thomas mentioned, also OData. So you can actually, if you have the right, if you bought a set of data, you can now take that and suck that into your application using standard ways of doing that. Thomas mentioned in 7 we were creating a way of actually utilizing OData directly. Today we'll have to do that with an HTTP web request inside of NAV, but I'll show you how to do that as well, so that you can actually use these data if you want to. The idea is that when you buy a number of data sets on Marketplace, you will get one invoice from Microsoft, and Microsoft will then get the money and then distribute those to the people who actually sold the data, with keeping a little share for Microsoft, of course. We don't want to go broke. So let's just have a look at what the Data Market actually is and how to buy data, browse data, use data in C# and use data in NAV. The URL is datamarket.azure.com, and there's a number of the data that has free trials, as you can see here, and you can browse through those things. I actually discovered a new one today, which is the translator. The Bing translator is now available through Data Market as well, and it's free for up to 2,000 translation a month. So you can sign up for this and have the translator built into whatever application you have if you don't do over 2,000 translations a month. That's pretty neat. But let's have a look at my account and look at the data that I actually purchased or have a free subscription on right now. My data. So I have some Dun & Bradstreet lookup here, and I have some Microsoft Translate. I haven't tried using that yet, but I'll definitely will. The D&B lookup, come into this one, and I can explore this data set. And it's going to send me to a web page here where I can type in the kind of the query to the data set, because this kind of contains information about companies all over the world. And hoping that this doesn't take too long, I'll write company name Microsoft and Washington State, and, US, and query businesses called Microsoft in Washington State in the US. There are actually a number of those because it's listing all legal entities, but I can just, the top one here is actually the main company here. So this DUNS number is what is the DUNS number for Microsoft, and I can now take that one and then get more information about Microsoft from Dun & Bradstreet, like our financial numbers and stuff like that. Let's take a small Visual Studio application that actually uses this DUNS number to, it's called test DNB, and see how simple it actually is to query data from Data Market and get that into Visual Studio. So HTTP web request is the class that actually has existed in .NET since I don't know when, version 1. And as we can see here, there's a long URL, which actually is the api.datamarket.com/data, and entering this information will give me back the information that I need. As we can see, that the request here also takes a credential, which is my username and my password, so I cannot do this in a browser. But if I run this application, it's going to give me back the information. I'm going to print out the entire XML document here, and then I'm going to print the total number of employees as the very last thing to do. And the total number of employees is 90,000, and the XML is here. So again, it's a uniform way of querying data, and the URL for specifying the query on an OData feed is the same. So meaning that whenever we in NAV7 ship with OData out of the box so that people can actually query NAV data using OData, it's the same mechanism they'll use for actually querying data out of NAV, and we'll be able to suck in data to NAV using the same mechanism as this. So you could easily imagine that you had a query in NAV taking data from Dun & Bradstreet directly into your business logic inside of NAV, because you had a field there called the DUNS number or whatever, and then have a seamless integration with business information there. Just to show how this works inside of NAV. So if I want to actually have the code for doing this, it's a code unit. Let's see, a code unit called external web service. In this sample, I do not query. I do not query the data market. I query some other web service, but it's the same thing. You do a HTTP web request against the URL, and you get an XML document back, load that in, and then you use whatever mechanism to actually select a single node here. I could just as well do the other one. This code, if you take a look at that, looks very much like the C# code I just showed you in Visual Studio, and the reason for that is, of course, that .NET Interop actually is, you have the ability to use .NET objects directly, and it looks very much like. I think the main difference is actually colon equals instead of equals in C#. Else, it's almost the same syntax. So if you want to run this one to get external web service, what it does is it will give me the current stock price of Microsoft stock. As you could see, it's 25.575. As you can see here, that's moneyservice.msn.com, stock quotes, MSFT. So, but you could query whatever you wanted with using the same mechanism here. Back to the presentation. Yeah, and I'll definitely have blog entries on my blog on how to use Data Market to translate text. That's a funny one, and also a number of the other things here. SQL Azure. Thomas mentioned briefly SQL Azure in the keynote as a relational database in the cloud. They always maintain 3 copies of your data, and you can utilize, like, you can use SQL Management Studio, you can use Azure Database Manager to actually work with that, and there's also a mechanism for how to actually communicate directly with SQL Azure from NAV, and I'm going to show that. So, how do we work with tables, and how do we use this from C#, and I'm going to touch upon how to do that from Windows Phone as well. Let's just have a look at the SQL, the management portal. So this management portal is the one that's used for the Azure platform, and as you can see here, there's a database tab down here, and in the database tab I have a database called TimeRack, and I'll manage that if my computer allows me to. So it's a very simple time registration table. So the idea is that there's a field for username, project, and then a number of hours spent. And then I'm going to show how to create a very small Windows Phone application. That was wrong. Come on. There was an error connecting to the server, yeah, but then please let me fix that error. So, I'll just try once more here. That should be right. Okay, while it is connecting, okay, here we are. There's one table in this database called time entry, and we can look at the design of this one. We have a ID project, timestamp, duration, and then the location of the user while he added this entry, and then of course the username. So you can imagine if you have a phone and an application on the phone, it automatically knows where you are, so you don't have to type in your latitude and longitude, which most of you probably don't know where you are. Or you know where you are, but you don't know what latitude and longitude you are in right now. So I'll try to start the Works application here on my simulator and add like 10 hours on the Windows Azure project here and submit that. Next thing I'm going to do is to view the data, the database, and refresh it. Then we have like ID number 14, the project Windows Azure, 10 hours, latitude and longitude null. And the reason for the latitude and longitude null here is that the emulator actually does not know where it is. Well, fortunately I have the application here on my phone as well. So I can start the same application just on the actual physical device and type in 5 hours here on the same project, submit that, and I should be able to refresh this in a second and actually figure out where I am. I am right now at 51.2458, comma 4.4, yeah, whatever. But that's my current location. If I take those and put that into my GPS, that will actually tell me this location. So I'm able to, from Windows Phone, add data to this one, and I'm able to actually read this data from NAV. Let's just look at the action up here called get time entries. And that one's going to connect to the same data, SQL Azure database, and read out the data and give me Windows Azure, 10 hours, and the two nulls. If I press yes here, it's going to delete the record in the SQL Azure database. So I'll do that with this one. And the other one with my coordinates, I'm not going to delete that one. And if I go back to this one and refresh that, I'll see that the one of the records was deleted and the other one not. So how does that work in NAV? Well, let's have a look at that code unit called get time entries. Again, you have an OData feed for the Azure database. So HTTPS OData SQL Azure Labs blah 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 blah, and then using .NET Interrupt to actually loop through the data in my data feed here. So on this one, I've actually selected that I do not want any security on this one. So I'm actually able to actually use a browser and type it in here, and I'll get the same data back in a browser here, where I can see that my time entry is 5 hours and my username and my project and all of these things, right? So very simple to work with if you have standardized ways to communicate data, and OData is becoming more and more the way of going forward. The project on the Windows Phone, I'm going to show a number of things later on how to do stuff from Windows Phone, so I'm not going to go to that project right now. And again, some links here on how to get the SQL Azure and stuff like that. If you want to, as Thomas said, there's a free trial on Azure, and you'll have that for a period of time, and then you can investigate what it actually costs to run databases up there. I don't know. Windows Azure Storage, the blob store in Azure. I'm going to go through that in detail in the end-to-end scenario on how to actually use the blob store to have images sent from the Windows Phone up into the cloud, and then actually get them down from NAV and show them on the client, meaning that the phone uploads an image, the service tier somewhere downloads the image to a local store on the service tier disk, and downloads the file to the role-seller client and actually shows that there. So I'm going to go more in detail in that in towards the end here on how to do that. The mechanism I use is found on Delay's blog, and he writes has a class that you can use for interacting with the Azure storage from Windows Phone, and you can also use that from NAV. And Windows Azure App Fabric is kind of the same thing. That's a service you can use as well if you have an Azure account. The App Fabric contains the most interesting thing for NAV is the service bus, which is used to connect cloud or on-premise system to other on-premise systems. The secret about the service bus is kind of displayed here. As you know, if you want some application to communicate into an on-prem NAV, you will have firewall issues. You're bound to have, like, nobody have their web services like exposed directly to the internet so that everybody just can communicate with that one, and nobody likes to have their NAV on the outside of their firewall. So what App Fabric does, or the service bus does, is that you're able to actually host an endpoint on the other side of the firewall in the cloud. And the way that works is that instead of the cloud connecting into you, you connect out to the cloud and actually expose the endpoint out there, and people can then connect to that one and be rerouted to your internal endpoint on the inner side of the firewall. Much like you do when you communicate with people using Messenger or whatever, Messenger connects up to a service in the cloud, and then people can then send you chat messages and stuff like that, or web pages. So this is also you're able to utilize the same mechanism for systems talking together on NAV, where, of course, you can have a first level authentication so that only if people knows a certain set of credentials, they'll be rerouted to your service, else they'll just be rejected on the App Fabric service bus, and then you can have second level authentication on your proxy. NAV is not capable of directly exposing endpoints in the cloud. You have to write what's called a proxy in order to do that, and there's a couple of examples on my blog how to write these proxies and also how to actually expose these proxies on the service bus. I'll also show that in the next walkthrough here, and again a number of links to where you can get more information on this. So the last like 40 minutes, I'll go through a end-to-end demo of a Windows Phone 7 application, some modifications in NAV for a service orders company. So the idea is that that you have a company doing service orders on maybe printers or hardware or computers or whatever, and what you typically have is you have like a dispatcher sitting, and people call in and say my computer is broke, and he'll type in a service order, and based on what he typed in, the dispatcher is then creating the service order and then assigning that to a technician that would maybe visit the customer then the day after, or depending on how urgent it is, maybe he'll call the guy and say, well, I need you to drive to that location after your current work and stuff. And all of this uses a lot of human interaction and maybe suboptimal, because the person that he wants to drive out there, he cannot see where they are right now and stuff like that. And what I want to show with this is that you want to utilize some of the unique capabilities of the device, where the device actually know where you are, so that you can have a look at the new service orders to see where are they close to me, and what is the priority, and could I take this one between my current assignment and my next assignment, because it's like right next door, and maybe the dispatcher is not in the able to see stuff like that. So I'll start out by doing the demo, and let's just see. Before I start the demo, I have to have a look at one thing here. NAV service orders, that's the name of it. So you could also imagine that the person sitting in the company would have a portal for actually creating service orders with the portal, or you could imagine that printers who actually today give you an information that they're out of paper could even report themselves as failing towards the service order company if there was a web interface towards that. So I'm going to have my Windows Phone here. This Windows Phone is now an application running, or not an application, it's a Windows Phone belonging to a technician somewhere in the field. And I have a dispatcher role center here. So this is the dispatcher with the service orders. And up here we have currently a website, but this could be, as I say, a service somewhere that actually that runs in the printer or whatever. So if I click here, this device will report itself as broken, and what happens is that, of course, automatically a service order will appear in the service order system, and the technicians will be informed that there is a new service order, if everything works well. As you can see, the phone up here said new service order created, and actually if the technician click that one, it's going to take him directly into the service order application. And the service order application here enables him to see all the service orders that are assigned to himself. Currently none. Maybe he's not busy. Going here, clicking F5 to refresh the view, you can see that there's a sales order number 79 created automatically here for the Canon group. And if I double click at that one, I can see, of course, it's a high priority thing and blah, 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 blah. And I can see the prioritized list here as the technician. I can see that there's a high priority service order at the Canon group. And again, the closest, I can also see the one here, which is like 0.2 kilometers from my current location. I can see that there are a number of service orders here, but of course I will take the one that is a high priority one. So I'll have a look at the prioritized list and say, well, this one is close by, and of course I'll accept that one as well because there's 2 service orders from the same company. And I can even see more here if there were more for that company. So I'll click on this one and have a look at what's actually broken here, and that's an enterprise computer close by. I can click the phone number here, and of course the Windows phone would then automatically dial that guy. I could click the email, and I could send him an email if I wanted to do that. That's probably not necessary right now. I'll just accept the service order and say yes to that. Accepting the service order will communicate with the service tier over the service bus, as I talked about a moment ago, and notify NAV that this technician now wants to actually accept this service order. Typically that wouldn't take so much time as it's taking right now, because it kind of needs to make sure that nobody else has accepted the service order, so that's why it's waiting for information for that one. That was not a good sign. Let's just take service orders again to see if I now have one assigned to myself. The high priority one is not. I'll just take this one instead to see if that works. Service order is now assigned to you. Well, I hope it's not a problem that I cannot accept high priority service orders. Now I got this service order assigned to me, and I should be able to see now that if I open service order 1 here, then this is assigned to Freddy. And it's right now pending, and if I say that, well, right now I want to figure out how do I get to that customer, so I click directions. It's going to take my current location, which of course is here, the metropolis here, and how to get from my current location and to the Canon group, which is just the opposite side of the street here, is actually pretty cumbersome, but I guess that's because of one-way streets and stuff like that. So going to the customer, and when I'm there, I can now signal that I'm actually starting working on this, and that information should be written in NAV as well. Now I'm doing the political way of saying should be written because I just found something didn't. Okay, it says in process now, so that's a good thing. And now I can take a picture with my phone if I have like the broken part or whatever, and I need some documentation on these things. I can attach an image to the service order, and I can attach a note. So I can click the note and say works now, maybe works now. Save that, and then when I'm done, I'll simply click done, and the order is now has now status finished. And actually, if I click over here, it should also have status finished. And I should be able to open that one and see that there's a note on the right-hand side that says works now, and the service technician that actually has created that. And there should also be information in the invoicing information about when did I actually start this, and let's see what we have here. No, it's actually here, starting date, the time when I actually started repairing this guy, and I ended up like only 40 seconds later completing that. So the response time here is very fast from when he actually said that the item was broke. Oh, that was yesterday. Okay, one day, because I took the wrong one. Anyway, so based on that, I can't take a picture with the emulator here. I need to take a picture with my physical phone. I could take a picture of you guys, of course, but I did that a little earlier, standing in the corner in the keynote. So in this service order, there should be a couple of pictures attached, and the service technician should now be able to say order images and then get a list of, or get downloaded and show the images that are attached to this service order. And depending on my luck, this should be the people in the room when they did the keynote, and there should probably be one more behind this of the actual presentation here with thanks to Michael. So this was kind of the demo first of what you can do with the phone, what you can do inside of NAV, and everything just magically works almost. The next thing I want to do is to go through how this was actually built, and then show that in detail. I'm not going to go into Visual Studio and do it. That would take far too much time. But I have included code snippets in the presentation here of how the various steps are, and since the presentation should be available, these things should be useful to work with. The components that have been created here are some customizations in NAV. There's a proxy that exposes an endpoint on the service bus. It's written in C#. It's a standard Windows service. There's a Silverlight application on the phone, and there's an Azure account for doing the service bus communication and the Azure storage for the image and stuff like that. Customizations in NAV is the service order card. Whenever anything is created, I'll send out notifications to all phones. That's done from within inside NAV using .NET Interrupt. And then the related information, show images, is also .NET Interrupt communicating directly to Azure storage. And exposing web services, the customer card, the service order card, and a special build code unit for a couple of things. The proxy, whenever you want like a phone to communicate with NAV, you need to create an API for that communication, for that purpose. And I think it's important for whenever you do these things and expose this on the internet, that you expose an API that is not generic, but is very, very tailored towards the usage of the phone here. So what the phone needs to be able to do is it needs to be able to get the service orders. It needs to be able to accept service orders, change the status of service orders, attach service order images, attach notes, and the last one is actually like just one for plumbing purposes, the register VP7 channel URI. But as you can see, the API here is very tailored towards the specific need of the phone, and not like a generic one where I actually re-expose the page through the web service, because I'm unable to see what attack surface that would give on my service if I were to expose too much. So very specific. The proxy connects, of course, to web services using a dedicated username, runs as a Windows service, and it also reduces complexity and reduces the number of round trips you have from the phone. If you were to communicate directly from the phone to NAV, well, in some cases, as I'll get back to in a moment, you actually do need a number of calls to NAV to get the service orders that are assigned to you and the service orders that are assigned to nobody, and then get the location of the customers and stuff like that based on that. The Windows 7 app, connecting to web services via the service bus to get all of the things in the API and connect to Azure Storage to store image. If you want to try out and play with Windows Phone 7, the developer tools are free. There's a lot of stuff out there for creating apps for Windows Phone. Of course, being Microsoft, created the app on Windows Phone. It would be just as easy probably to create it on iPhone or Android, because what I use via the service bus is standard HTTPS web services, so you would be able to write an application doing that. I won't help you do that, of course. And then the Azure account for using the service bus and our Azure storage. So, step by step, what actually happened when I did the demo. The first thing is that whenever the proxy starts, it needs to expose itself on the service bus, like start up and make so that people can connect to that one. And of course, connect to NAV service tier via web services. The way that this works is very similar, so the code is here, is very similar to when just creating a normal service host, a normal proxy, and there's a good explanation of how to do that in 10 minutes on my blog. There's a video actually where I go through from starting Visual Studio to creating an installable proxy and a test application to test that. And in that one, I do the same thing. I create a service host with the proxy class in it, and then add a number of endpoints, and then open the service host. What's in between here is that set up the shared secret credentials. These ones are the credentials that I need to be able to host an endpoint on the service bus. So given that, these issue name and issue secret is what I get from my Azure account. That's kind of my login to Azure to be able to host something up there. So nobody can, so everybody can't just host something on my account. And then I have two bindings. I have my service bus binding and I have my HTTPS binding, both using, instead of basic HTTP binding, using something called basic HTTP relay binding. And the relay word is the one that tells you that this is a service bus hosted service instead of the normal service. So, and after this, whenever you've hosted the service, you don't notice the difference. Your proxy, the code inside the proxy is exactly the same. So the entire complexity of hosting something on the service bus is on the registration of the service and not on actually doing anything after that. A link to the SDK and all of these things. So another plumbing thing I talked about was registered WP7 channel. The first thing that happened whenever a user starts an application on his Windows phone is that it registers that now there is a user for this phone for this application on this phone, and what happens is that it calls the Windows Phone services and gets a notification channel URI. This URI is basically a HTTP link that whenever you send the right XML document to that link, a pop-up will appear on the phone, and then when you click that pop-up, the phone is going to start the application registering itself on that one. What I do with this link is, of course, I send that through this register VP7 channel and write that into a table in NAV. And if we have a look on that one, just real quick here, called WP7 channel. Oh, I'm on a different machine here. Sorry. So here we are, WP7 channel. Run that one. We can see that Freddy here is actually the user in my simulator here, Windows Phone Simulator, and Freddy K is the user on this phone. So this URL, pretty long and not something you can just guess, is a unique notification. Whenever you send the right XML document to that one, well, this phone is going to pop up a message saying that there's a new service order. So that's as simple as it is. Back to that one. So this URI is now written in a table inside of NAV, so that we actually now can use that one to send messages to the phone. So what happens is that whenever the user creates, the code here, I almost forgot that. The code for getting the notification channel, you give it a application name so that the Windows Phone is capable of finding your application again. And then send URI to service is the one that you want to send it to NAV. This one, what it does is it creates a proxy client for my proxy on the service bus, and then it calls this register VP7 channel URI async. The async is that the phone cannot do synchronous web services, it can only do asynchronous web services. The proxy, what that does is it just takes whatever it gets in for the channel URI and actually calls the corresponding method on the NAV web services by setting up a service connection to NAV, authenticating the user, and calling register WP7 channel URI on NAV. And in NAV, of course, there's some AL code here for putting that into the table so that it's updated always in the table. Based on that, whenever the user now creates a service order, or the system, like a web page, adds a service order to NAV through web services, NAV service tier will now send a toast notification to the phone. And as I said before, this was done by creating an XML document and actually sending that to the URL that's in the WP7 channel table. And since this is a broadcast, we'll just loop through the entire table and find whatever URLs is matching my application, and then we're going to send this document to all of these. Creating the XML document, I could do that as a string, but I'm selected to use .NET interrupt for that, and then use standard nav error handling, the code unit.run. If something goes wrong, maybe an application is unreachable, the phone is off or whatever, will actually cause a exception to be thrown, and we don't want the service tier to crash on that one. And I'll send the request using HTTP web request and web response. So this is looping through the VP7 channel table, and the do send toast notification creates the XML document, and if you know XML document and .NET interrupt a little, you'll see that we create an XML document. Underneath that, we'll have a tag called notification. Inside of that, a tag called toast. Inside of that, a tag called text1, and next to that, a tag called text2, which have actually the actual text that you want to display on the notification on that phone. And then you send the push notification, and doing that by setting the variables in that code unit and calling run on the code unit, which then would enable you to use the web request here and send the message directly over to the phone. So by doing this, I haven't created one single DLL yet in C#. I can actually do everything here in NAV. So the next thing is the phone, whenever he clicks the notification that he gets, starts up the application, and it needs to actually get the service orders from NAV. And of course, as we saw, there was an entry in the API called get service orders, and it's going to call the get service orders, and then the service orders are going to get back to the phone and going to be displayed in a prioritized order or a closest order on the phone. So the phone invokes the get service orders. The proxy reads the service orders from the card page, and it does that in two loops. First, reach the one that are assigned to myself, and then reach the one that are assigned to nobody. And then it actually builds the collection of, and then returns that to the phone. It also reads the location of all the customers. So it actually, for every single service order, does one more call to NAV web services to actually read the location of the customer. And then last, the phone actually calculates the distance from its current location to each service location. In the beginning, what I did was I just let the phone actually transfer the current location to the proxy so that the proxy could calculate these things and actually figure out what's closest and what not. But then some guy told me that that was a privacy issue because service technician might be sitting on a bar somewhere watching a soccer game, and he didn't want the server to know his current location. And well, I told him that nobody was looking at that, but well, privacy is privacy, so we decided to go with all service orders goes to the phone, and the phone actually calculates the distance then, which is the distance in flight and not actual distance on the road. That would be too hard, I think. So the code for these things: load service orders on the phone, calls the get service, or gets the proxy again, and then it sets up a completed event, because of the asynchronously call, that whenever you're done with my service call, then call this client get service orders completed function, and then we call web services from the phone. At this time, the phone is again responsive. You can take calls and you can do whatever you want. The phone is just waiting for the response from the web service. And if you leave the service orders application and go take a phone call or shut down the phone, then this response will just get lost. And then whenever you start the phone application the next time, it's going to do another web service call, and you get the response back at that time. So that's the reason for the asynchronously. The phone is primarily a communication device and needs to be able to do that even though an application is running, right? It would be bad if during this time frame you can't call me right now because I'm waiting for a web service response. The get service orders in the proxy, if you remember some of the code that were whenever, I actually didn't show this, but if you've used web services towards NAV before, you're setting up filters. So we're setting up a filter up here for the service orders that are assigned to me. So creating a filter on the field assigned user ID, and the criteria would be a case insensitiveness of my own user ID, and then calling web services read multiple with this filter will give me all my service orders back. After that, I'll set the assigned user ID to nobody, so give me all the service orders that are assigned to nobody, and then last but not least, I'll collect those in one array, and for each one of these actually read the customer card service and add some information to that with the latitude and longitude of my customers. Return that to my phone, and then the phone will run through these guys and actually distribute those on the various desktops by update collection here, and calculate the distance between my current location and the service order location. And calculating the distance between two places with latitude and longitude is a very simple formula given here. I guess everybody can knows that, or everybody can at least find it on Bing. That's what I did. So accepting a service order, a very simple thing that needs to happen on the phone. We click the button, and it just communicates with the proxy and calls accept service order, and that's written into the table, of course. The only caveat here is that we need to wait for the response, because somebody else could have accepted the service order as well, and we need to actually make sure that nobody else took that. So we have to set up a completed event again and call the accept service order async, and in the order completed, then check whether or not we actually got the service order. We start out by asking whether he wants the service order, which may be stupid because he just clicked the button. The accept service order method here on the proxy will create my NAV proxy, call the authenticate on that one, and then read the service order, set the assigned user ID, and update it. And if somebody else have done the same between the time where I read it and between the time I updated, this will throw an exception, and I'll return false to the phone app, else I'll return true, meaning that now you actually got the order. And then on the phone, again, you're going to display that the service order is now assigned to you, or the service order was already assigned to somebody else, either because the dispatcher did that or somebody else using a phone was quicker than you were. Change service order status is more simple because now you have the service order assigned, so I don't need to wait for information. I actually just send the information over, and it's set to in process when changing the service order, and then business logic in NAV is going to set the starting time and all of these things, and that's part of the page already there. So on the phone, it's just initializing a proxy client and then calling out to change service order status. And the change service order status is just calling on with the same information to NAV web service. Next thing is that if the user takes an image, he can, on the phone, he'll take the image and actually upload that to Azure Storage. And after that, he needs to notify NAV of the URL to that image, so that NAV is capable of finding that image on storage. I don't actually upload the entire image to NAV. I just upload it to Azure Storage because that's a cheap way of doing that. So, again, Delays blog has a good information about how to do that from Windows Phone, and the code on the phone for interacting with like the camera and the email and all of these things is something called a task model. You have something called a camera capture task, and you instantiate that one, and then you say show. When you say show to that one, the phone switches to the camera, and whenever you're done, you get this accept or reject, and if you accept the image, you will get it back into some code that you have in your app. What I do here is I resize the image so that it's not as big, so easier to upload to Azure Storage. And then I use this blob client to actually upload it into Azure Storage using my account name and access key that I got from my Azure account. And there's a couple of events here to handle that. After that, I have a URL to an image stored in Azure Storage. Of course, that doesn't make NAV capable of downloading the image because it doesn't know where it is. So what I can do is I need to take that URL and send that to NAV. And doing that is pretty similar to sending a note to NAV. And so attaching an image or a note to a service order actually also just updates a table of images. Let's see, so the phone calls in and say attach service order image or attach service order note in the proxy. And it actually displays in a message box when the image is updated. And the proxy just calls over with the same information to NAV, and then there's a code unit in NAV that handles these things. So the image, I set up a completed event because I need that one, and say image uploaded. And for the note, I just call service order note, or attach service order note, and navigate back from my note page. The proxy is pretty similar. They just take the information they get and call over to NAV web services. And in the code unit, attach order service order image will always just create a new record in the service order image table. The attached service order note is going to create a record in the record link table with the right formatting, stuff like that, in order to actually get a notification added to that one. So if anybody have tried this, the secret here is that the first character of the note needs to contain the length of the remaining characters. And that's kind of the way to create notes in the record links table. That's how NAV does it automatically from the Rotator client. Having those gives me the ability to now, from the Rotator client or from the service tier, to download that image that I got the URL from. The phone uploaded the URL to an image in Azure Storage, and I can now download that to the service tier and then use file download to get it down to the client and actually show it. And the code used for downloading the image is utilizing an Azure Storage class that wraps the blob client from Delays blog. I found out that there is actually in .NET a library for doing this. I don't need to write my own at all. But so I'll update that at some point in time. Just using the standard .NET way to do that. So on action, we're using the Azure storage mechanism here to call over and get the blob down to my temp path service order image and use the same name, and then take a file download of that down to the client. So, meaning that when I do the file download here, I've set up that whenever there's a JPEG, I actually just want to open that one, and it opens up in Paint, and I can see my pictures here. Of course, I could have added a control on my page as well. So, okay, there's a number of links here to all of the things that are in this presentation. And again, the presentation will be available for how to get started on all of these things. This entire end-to-end presentation will be available on my blog sometime during October here, in detail on how to create all of these things. Questions for this, or was it totally confusing, or are you still awake, or? I actually can't see because of the lights.
2 questions. So one, do you really have to use the service bus to do this communication, or was it just purely for exercise purposes, like the communication between Windows 7 and Vision?
So if I want to communicate with an NAV that is sitting behind a firewall on an on-prem solution, you can either open up a port in the firewall, and then you have the communication directly, of course, or you can use the service bus, or I guess there are other mechanisms out there like the service bus that you can use. But else, I can't see how you could get to the on-prem NAV if you wouldn't. The nice thing about the service bus is that it removes the complexity of having to deal with IT organizations. If you go out with a standard solution to a customer, and they have an IT organization, well, we don't want to mangle around with our firewall and stuff like that. That might be hard to install if you use the service bus. It's something that the application can do itself. It just registers an endpoint on the cloud, and where it actually opens up a channel going out, and that's possible on even on CorpNet. My server here is actually placed in Redmond inside the Microsoft firewall, and I have yet to be in a location where I cannot connect to that from the outside.
Sort of expanding on that, I guess. I mean, they kind of touched on the opening keynote as well. What is it in the near term, say 1 or 2 years? What is it exactly that the Vision and Azure you guys see we get to do with it at the end of the day? Like, they say NAV 7 or in the cloud. I mean,
so if the question is what exactly NAV is going to do in the cloud in the next couple of years, I can't answer that question. They didn't answer it on the keynote, and we're still investigating what is the right position for us. I think the best term to say, if you remember the slide that Thomas had with infrastructure as a service, platform as a service, and software as a service, I think what we want to do is we want to have NAV be a platform as a service, so that our partners and ISVs can create a software as a service based on our platform to sell to volume customers.
So in the short term, basically the actual backend, the SQL database and everything, the old data is not going to be run. There's no plan to have it up on SQL Azure, to have like basically the entire application in the cloud.
Don't get that question. Oh, could you repeat?
Well, I mean, the way I thought where this was going was basically running the actual Vision application, the database on SQL Azure.
Yes.
So basically then you would have the entire Vision up in the cloud.
Yes.
I guess
that
the
is
whole software.
That is what we want to do.
Okay.
We want to utilize SQL Azure as our database, having NAV platform running up there together with an application which is not just the standard application, but an application that is suited to a certain vertical or whatever. So that's the idea. And we don't want to I mean, there are hosting partners out today, like SaaS Plaza, and I don't know if there are other hosting partners, but I know SaaS Plaza. And we're not in the game with Azure to compete with SaaS Plaza. What we want to do is we want to have vertical solutions that sell in volume, and SaaS Plaza will take care of customers with unique requests like they do today, and they do a good job on that. So, and whatever we do of changes in NAV will just make it run better on their hardware as well as going to run better on Azure as well.
Any more questions?
Thank you. Hi, Freddie. A question going back to the beginning of your presentation when you were talking about the CRM connector under the bonnet, and we saw the demonstration of the integration records. Am I correct in understanding that this is a framework that we can potentially use for our own integration scenarios, because we can extend the scope of the tables that get included in that?
Yes, absolutely correct. And that's the reason for demoing it in this way, instead of just demoing how to set up maps and stuff like that in the connector. So yeah.
Okay, so in that case, it seems to deal very nicely with records that are created and modified and deleted in NAV. But is there something in the framework that could deal with a record getting created by the third-party application that you're integrating to?
Record, so getting data from the other vendor?
Yeah, sure. Say the POS application that you're integrating to, it creates an item, and that item record needs to then come into NAV.
Well, that would have to be, the reason for this is that by now, until now, it hasn't been possible to, from the outside, to query what objects in NAV has changed since a given time. Whatever application you're integrating to might have that functionality already, so you can ask, so what objects have changed since a given time, and that you would use that for that. The question is whether you want to from NAV query, or you want from the other application actually to write data into NAV, and I think that's a case-by-case decision on what the best solution is for that. And what I showed here was a pull mechanism, meaning that an application in Visual Studio could query NAV and sync data into something else. It could be that you wanted to, inside the integration management code unit, actually send a notification to somebody to say, I just changed something in this table. You wouldn't do that with all changes, but in some tables it might be that, well, changes to this table actually always needs to be replicated somewhere, so you could utilize a push mechanism. All these things depends very much on what data it is and what application it is. So I think it's a case by case. Some might be easier and some might be harder.
Sure, okay. And you touched on there that to implement this integration records table, you had made some changes to the global triggers that are associated with the NAV tables, so they always fire. No,
I said we added 4 new triggers called on-database triggers. So they are now the on-global triggers, and then the on-database triggers. And the on-database triggers are truly global. I know that it's a little weird, but we couldn't change the on-global triggers to just be fired at any time, because of, people who use those triggers for certain purposes might then break code. So we added on-database triggers, and on-database triggers will always be called, even though you update it from code, or you do it from the UI, or do it from web services, or whatever, then they are called.
Okay, I know it's slightly off-piece from the subject of integration, but does that mean it might have an impact on how changelog works, so that we can get changelog entries with...
We did not change changelog to run on the new triggers.
Right, okay.
It's compatible with how the old data is, how it works, always worked.